Hello students, welcome to your Venturi Meter Lab. My name is Daniel Barnard, I'm the fluid technician here at CPUT. Again, we'll look at your lab guide, go through the paperwork, and then the next videos will show the equipment we're going to use and how the data is actually captured. All the links to the documentation, data and videos will be sent to you by the lecturer. Alright, here's the lab guide for your Venturi meter. First page is the table of contents of the lab guide. First section at the top is the aim of the experiment, and it is to determine the discharge coefficient for the Venturi. Second section, what you need to do, please have a good read through this. It will guide you what you need to do to finish this lab. Then we have some theoretical background and the diagram of the Venturi and an explanation of the schematic. Next we have the experimental apparatus. There you can see the workbench again, where the Venturi will be connected to. And there's the Venturi itself with all its parts, and the Venturi is obviously sitting here at the bottom part, and that's the inverted manometer. And then we have the experimental procedure and the results. There's a quick explanation of what we want in the results, and there's some formulas for you to guide. And the next is a sample of the data table you will receive again. There you can see it's the inlet head, throat head, rotometer flow height, time to fill 5 liters, head difference, actual flow rate, and theoretical flow rate. And then at the bottom is a description of what data you will receive, raw data, and which data needs to be calculated. And then on the large page there is some further reading and an example of the results we need. The equipment we're going to use for the Venturi Meter Lab, again we're going to make use of the hydraulic workbench with the rotometer fitted to it. If you have any questions related to the rotometer and how we capture the flow, please refer to the video again, the rotometer calibration. That will go through all the steps. Connected to the outlet pipe of the pump is the Venturi meter. The Venturi meter is this bottom part over here. Then we have control valve, and again the pipe drains into the small basin, which allow us to do flow measurements. Now connected to the Venturi is an inverted manometer, and the 2 points that we are interested in this lab is the inlet of the Venturi, that's the very first one, marked as H1, and we're also interested in the throat, which is this one over here, and marked H2. Currently the control valve of the rotometer is fully closed, and you can see that the pressure in the inlet and the pressure at the throat is exactly the same, because there's no flow through the system. The purpose of this lab is to determine the discharge coefficient for the Venturi, and for that I'm going to show you the procedure how to capture the data needed. For the Venturi Meter Lab, we also require these constants at the back. We're going to be interested in the inlet, we need the diameter and the area of it, and we're going to look at the throat, and we're going to need the diameter and the area of it. All these constants will be provided in the data set you will receive for this lab. The procedure for this lab to capture the data is as follows. We're going to start with the rotometer, and we're going to put it on 0. Remember that the reading edge is the bottom edge of the rotometer, of the float, and there is some flow going through. Just wait for this bubble. Right, so we need to capture the height of H1, and again this is in millimeters. We're going to capture the height of H2, which is also in millimeters, and then we need to measure the flow exactly the same way we did when we did the calibration of the rotometer, by closing up that small basin inside. We're going to take a look at the side glass, and we're going to measure how long it takes to fill 5 liters of water. So remember, these segments are marked in 5 liters segments. So the water will rise, I start my stopwatch, and I stop my stopwatch. Then I know how long it took to fill 5 liters of water, and I can calculate my flow in liters per second. If the water is a bit bouncy, just remember, wait for it to settle, and then you might have to take a reading from this line to that line. It doesn't matter which increment you use, as long as your water level is stable. Then once we've done that, we're going to set our rotometer on 20 millimeters. So again, the rotometer, we will do increments of 20 millimeters. Again, we're going to take our inlet head reading in millimeters and our throat head in millimeters. Now you can see the head difference is changing as more flows go through the system. And again, we measure our flow and we do our next step. We jump 20 millimeters on the rotometer, and again we take our reading for inlet and we take our reading for our throat, and we measure our flow for that increment. All the raw data and constants required to do this lab will be provided by your lecturer. Data sets will consist of your inlet head, your throat head, and the flow for the specific rotometer float height reading.